Okay, y'all, we are back for some more stoichiometry. We're on pages 3 and 4 of the homework packet. As a reminder, you have to show work, okay? The work is the point. There's a method to the madness. No work, no credit. And work for any chemistry math problem starts with boxing in the given and circling the unknown, okay? Let's start by looking at 2 and 4. So we're looking at this balanced equation. It's the synthesis of aluminum and oxide, and number 2 is asking you for the mole ratios. So it wants the mole ratio of aluminum to aluminum oxide. It's asking you for coefficients, okay? This just means coefficients. So for aluminum, 4, and for Al2O3, 2. And don't put 1/2, leave it as 4 and 2. We don't worry about reducing that. Number 4 is talking about oxygen to aluminum. So oxygen, 3, to aluminum, 4. So whatever is written in front here is written in front there. Okay, there's quiz questions and test questions like this. Basically, the mole ratio is when we do the mole-to-mole step in stoichiometry, the numbers that we plug in. Okay, we're going to jump down to the bottom of the page because we do a lot of the top ones with you in class. Okay, looking at this one, we've got 2 aluminums plus 3 zinc sulfates yields 1. There's an invisible 1 there. Aluminum sulfates plus 3 zinc. All right, it's a single replacement reaction. And we're going to box and circle. So, number 9 says to use up 25 moles of aluminum. Okay, number, unit, compound. All of those are boxed in as a given. How many grams of zinc sulfates are needed? Okay. Now, I'm going to start by showing my work all the way over here on the left, because I'm not telling you if this is 1 or 2 steps. Like at the top, I showed you. But here we're expecting you to know. So I'm just going to start all the way over here and give myself plenty of room in case this problem drags on. So whatever I put in the box comes in my first box. 25.00 moles. I'm going to look at my equation. Aluminum is just Al. It's not Al2, so Al. Moles of aluminum. And then I'm going to take my whole unit and bring it down. Moles of aluminum. Okay, and I'm going to do it in pencil because I can't do this. I cannot turn this into zinc sulfates. Okay, that is a no, no, no. If I'm changing compounds from aluminum to zinc sulfates, it has to be mole over mole. That's the only way to change change compounds. So if I need to turn this into zinc sulfate, which I do, I have to turn it into moles of zinc sulfates first. So I'm going to say moles of zinc sulfates. And how did I know the formula for zinc sulfates? It's the one that has zinc and sulfate in it up here. So I copy down whatever's written there. Okay? Well, that's fine. That's not what I'm stopping at, though. So I have moles on top, not grams on top, which means I can't stop. My problem needs to keep going. I'm going to just go down again, moles of zinc sulfates. Okay, and now, since I already have a zinc sulfate, I can turn it into grams of zinc sulfate. So always, 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 one does not simply do stoichiometry without doing mole to mole first. So my question wants me to change compounds. I know I have to go to moles before I can do that. Okay, so a mole always gets a 1 in front of it, unless it's mole over mole. These guys get the molar ratio. So I need to look at my balanced equation. So for zinc sulfates, it's 3. For aluminum, it's 2. So I put a 1 in front of the mole, except for my mole over mole. And then for this one, 1 mole equals, just like we did last unit, molar mass in grams. So that means we have the joy and the privilege of finding the molar mass of zinc sulfate, which is a little bit of work. Okay, so I need 1 zinc, it says right there, plus 1 sulfur, plus 4 oxygens. Okay, I'm not going to multiply that by 3, because my question, I'm doing 1 mole for the molar mass. So let's see if I can show a little bit of this on the calculator. Zinc is 65.38 plus 1 sulfur, 32.066, plus 4 oxygen, so parentheses, 4 times 15.999 gets me a molar mass of 161.442. 161.442. Okay. Now I multiply by each of the top numbers and divide by each of the bottom numbers. So let's get that started. 25 times 3 times 161.442. Okay. Divided by 2 on the bottom. Divided by 1 on the bottom. 6,054.075 grams. Okay. I'm going to make sure, let me switch to blue. 6,054, I'm just going to put 0.075. I don't have to put all of it, but I'm going to, just to be safe. And then we need a unit, which didn't fit in the box, but that's okay. Moles of aluminum is on top and bottom, so it cancels. Moles ZnSO4 is on top and bottom, so it gets crossed out. But grams of ZnSO4, even if you have to add that in on the side. Okay, let's go to the back. I'm going to do a couple with you on the back. Okay. Number 11, we're looking at combustion reaction. Propane plus oxygen yields carbon dioxide and water. It's a CHO reaction. It's a combustion reaction. Boxing and circling. Okay. When 4.5 moles of propane react, how many grams of carbon dioxide? Right. So I'm going to start all the way on the left, leave myself room. 4.5 moles of C3H8 propane. And I know for sure I disco that down. Mole C3H8. So at the very least, every student should be able to do this. I boxed and circled. I put what I boxed here, and I disco down the unit. Okay. I know my answer needs to be a different compound. I'm changing to carbon dioxide. And the only way I can change out of C3H8 if I want to make this into carbon dioxide is by going through the Moultrie. You have to go mole to mole, like that. That's not my final answer, because I want my final answer to be grams. So I'm going to disco again, bring down moles of carbon dioxide. And since I already have carbon dioxide on the bottom, I can turn it into grams of carbon dioxide on the top. Okay. Now, I strongly encourage my students, Mrs. Holmes students, to do all of your units first. Units are your best friend. Don't worry about any numbers until you have all of the units down. And then my first question is always, what goes in front of mole? And the answer is 1. A mole always gets a 1 in front of it, like mole over grams, unless it's mole over mole. For these people, I need the coefficients out front. So for mole CO2, I put a 3. For mole C3H8, I put invisible 1. Like that. Okay? Make sure you're writing the CO2 so you're not getting confused what's what. And then always in front of grams, we put molar mass. So I need to find the molar mass of carbon dioxide. So 1 carbon plus 2 oxygens. So I'm going to say 12.011. That's my 1 carbon right here. Plus, plus 2 times oxygen. 44.009. Okay. So I can do my math. Top times 3 times 44.009 divided by the bottom, divided by 1, divided by 1. Stays the same. 594.1 I'm going to put. I'm going to switch to blue. 594.1. And with units, okay, I have lots of units written there, so I need to figure out what cancels out. Mole C3H8 is on top and bottom, so it's gone. Mole CO2 is top and bottom. Grams CO2 is the only one left. Grams of CO2. Like that. Okay. So both of those first two problems I did with you started in moles. Number 12 is not starting in moles. Number 12 is starting in grams. So 25.0 grams of oxygen is how many moles of water. Okay? So we're in a different starting place, but it's the same process. So we're going to scoot over, and what I boxed in goes here. So 25.0 grams, and it makes a difference. So look at your equation. Oxygen is there, and the equation reminds me that it's O2. It's one of those diatomics, and yes, that makes a difference. We're going to just go down grams of O2. Okay, I'm going to do this in pencil because I'm not allowed to do this. Moles of H2O. That's a double no-no. Okay, I cannot go from oxygen to water unless it's mole over mole. I don't even have mole on the bottom right now. So I definitely cannot get to water until I am in moles. Not allowed to change compounds. So I have to get myself to moles. So from grams of oxygen, I need to go to moles of oxygen. Okay? If I have grams on bottom, I have to keep the same compound on top. Here I had moles on bottom, so I could change compounds right away. Here I have grams on bottom, so I can't change compounds yet. But if I turn it to moles on top, and I bring that down for the next step, mole O2, now that I have mole on bottom, I'm green to go. As soon as I have mole on bottom, I'm green to go. I can turn it into a different compound. So now I can turn it into water, H2O. Okay? So before you can change compounds, if you start in grams, you have to get yourself to moles. A mole always gets a 1 in front of it, so moles over grams, that's going to be 1. Mole over mole, those ones are going to get coefficients. So for H2O, we've got a 4. For O2, we're looking at 5 moles. And then grams always gets molar mass in front of it. Now, if you grams as 15.999, you're going to get the wrong answer. It is O2. That's why I copied it down from up here, so that I don't forget to include 2 of them. 15.999 times 2, 31.998. And we'll do this. Okay, so there's my molar mass. So that gets me from grams of oxygen to moles of oxygen, from moles of oxygen to moles of water. And we're able to do that conversion. So 25 times 1 times 4 on top is 100, divided by the bottom. So divided by 31.998 equals, divided by 5 equals 0.62 or 0.625. I'm just going to put the first couple there. And my units, grams of oxygen cancels out, moles of oxygen cancels out. So the unit that I'm left with is moles of water, moles of H2O. Okay. So that's 2 of the steps. We're adding a third step next time. So make sure you're getting comfortable with this process. Come in for help. Down here we've got some review questions that hopefully we're going to be strong at. How many atoms are there in 1 mole of holmium? Okay. How many atoms are there in 1 mole of basketballs? How many atoms are there in 1 mole of M&Ms? The answer for how many are in 1 mole is always Avogadro's number. Okay. They're asking me how many atoms. Now this time they're asking me for molar mass in 1 mole of holmium. So 1 mole equals this many atoms, but 1 mole equals molar mass in grams. So we need to find this fantastic element, number 67. Molar mass 164.930 for B. Okay, so 2 different types of questions. How many atoms are in a mole and molar mass. Okay, then down here, please let's not forget this. This is my reaction. At the beginning of my reaction, I have the reactants. At the end of my reaction, I have my product, what I produced. So my reactants will be calcium and hydrochloric acid, HCl. My products will be calcium chloride and hydrogen gas. So safe-ish, super poisonous acid, Super flammable, dangerous gas. That's fun. I'll do that in class feed when we do acids and bases. Super scary and awesome. Okay. Good luck. Keep working.